Hello, calculus fans! There's a special case of doing iterated integrals where the integrand can be factored as a product of a function of x only and a function of y only. Then, if you want to compute a double integral, or an iterated integral, it can be written in a really simple way. To be specific, let's suppose that our integrand can be written as g of x times h of x, and R, the region of integration, is AB cross CD, just some rectangle. Then Fubini's theorem tells us that we can write this as an iterated integral. And this time let's put the brackets in just to help remind us that there's an inside integral and then there's going to be an outside integral. Notice that in the inner integral, y is a constant. So we can think of h of y as just some number. Anytime you have some number, that's this guy here, you can pull it out of the integral. Now we're just talking about the inner integral right now. But now we have that the integral from a to b of g of x, that's this guy here, that is actually just a number, so we can bring it out of the y integral. So the integral from a to b of g of x dx is just some number, so it can be factored out. So in this case, we can say that the double integral of f can be written as the product of two single integrals. So that is, this double integral can be written as the integral from a to b of g of x dx times the integral from c to d of h of y dy. These are now ordinary one-variable calculus problems. We compute them separately and multiply the answers together. So let's do an example. Let's compute the double integral over R of x e to the x squared plus y dA. And our region of integration is the rectangle 02 cross 03. So let's let f of xy be the integrand. Notice that we can do some algebraic manipulation. If you have a sum inside an exponential, that means you can break that up as a product. And now, because the integrand is a product of a function of x and a function of y, we can break up the integral. You see here, there's the function of x and the function of y, and so we can break up the double integral as a product of two single integrals. The second integral is really very easy. We get e cubed minus 1. Going back, the first integral requires a substitution. Here's the substitution that we would make. We would let u be equal to x squared, so that du is equal to 2x dx. Changing the limits of integration will give us new limits of 0 and 4. The x dx will have to turn into 1/2 du. So here's the new integral we get. Integral from 0 to 4 of a half e to the u du, piece of cake. We end up with 1/2 e to the 4th minus 1. That gives us our final answer. We just have to multiply these two results of our integrals together, and we're done. Okay, that's all for now.